There is a difference between a network diagram and a schedule. A network diagram shows the logical flow of work, while a schedule shows how the work will be done. The schedule needs to be realistic, something that can be actually followed and that can bring the project to completion as per the plan. There are analyses that can be performed to bring the schedule closer to reality. One such technique is called what-if scenario analysis. On a typical project, there are some good things that are going to happen, and then there are some bad things that are going to happen. These good or bad things can have a positive or negative impact on the schedule. What-if scenario analysis is used to evaluate such scenarios to understand what impact they may have on the project schedule. For example, there may be a labor strike in the middle of the project. If this happens, what will be the impact? The scenario is created in the schedule as if the event has happened to see how it impacted the project. What if there is extraordinary flooding during the rainy season while the project is going on? Again, a scenario is created and the schedule evaluated to understand the impact. Such analysis also help in coming up with time and cost reserves for the project, which can be used to come up with response plans to manage such scenarios if they actually happen so that the impact is mitigated. Simulation is another method used for what-if scenario analysis. The most common simulation method is called Monte Carlo Simulation. Typically, simulation is done by running various scenarios with different combinations of assumptions, risks, and issues that help come up with the total project duration. These combinations can run into thousands. Monte Carlo simulation is performed by taking a random number as the probability and then calculating the project duration from it. This is done thousands of times and the resulting data is plotted, typically in the form of a cumulative curve which is called an S-curve. A probability distribution can also be plotted, which almost always comes up as a normal curve due to the size of the data. Now if we read the S-curve shown, it tells us that the probability of completing the project in 9 months is only 40%, but the chances of finishing the project in 17 months is 90%. When the Toronto's Pearson International Airport terminal development project was underway, Monte Carlo simulation was used for analysis. This was a $4.4 billion 10-year long project. The master schedule had 5,000 activities. The S-curve resulting from the Monte Carlo analysis, which took data from a new method that I developed during my graduate research, showed a 10-month delay from planned completion with a 95% confidence. That is because on the S-curve at 0.95, the corresponding date was 10 months later than the planned completion date. The project actually finished 10 months late, exactly as predicted by the model. Therefore, these techniques are very helpful in analyzing schedule risks.